In a matter of months, up to $5 trillion is erased from the global economy. Coastal highways slide into the ocean. Entire agricultural sectors wither and die. Yet this massive disruption is completely natural. It operates on a predictable, cyclical rhythm that has existed for millennia. A harvest fails in India. Bread prices spike in London. Copper mines flood in Chile, choking global electronic supply chains. If we know this oceanic cycle repeats every 2 to 7 years, why does it continue to bankrupt industries and collapse supply chains with near-perfect regularity? We continue to treat a predictable climate pattern like a surprise party. That is a failure of anticipation. We routinely underestimate the physical chain reaction happening right beneath the surface. Take a look at this cross-section of the Pacific Ocean basin. Under normal conditions, strong trade winds blow from east to west. They act like a massive invisible plow, physically pushing and piling up warm surface water against the Asian coastline. But every few years, the system falters. Those driving trade winds suddenly weaken. Without the wind holding it in place, gravity takes over. That massive pool of warm water sloshes eastward, surging back toward South America and suffocating the colder waters below. This initiates the Bjarknes feedback loop. The warming Eastern Ocean heats the air above it, which weakens the winds even further. Weaker winds mean warmer water, which means weaker winds. The ocean and the atmosphere lock into a runaway cycle. This localized feedback loop acts as a planetary switch. Once flipped, it reroutes the distribution of heat and moisture across the entire Earth. This globe shows the Earth's jet streams. As that massive anomaly of heat shifts across the Pacific, it physically drags these high-altitude rivers of air completely out of their normal paths. Climatologists call these teleconnections. The first casualty is biological. The warm water flooding the South American coast shuts down the nutrient upwelling that feeds the Peruvian anchoveta. One of the largest industrial fisheries on the planet collapses almost overnight. That local extinction sends a shockwave through the global supply chain. Anchoveta is a critical base for global agricultural feed. When the nets come up empty in Peru, meat and poultry prices skyrocket worldwide. On the opposite side of the Pacific, the teleconnection has the exact inverse effect. Moisture is sucked away from normally wet regions like Indonesia, leaving parched forests vulnerable to devastating wildfires that decimate global palm oil and cocoa harvests. In Latin America, these shifted weather patterns starve major river systems. Hydro-dependent power grids fail, triggering blackouts that halt manufacturing and construction sectors entirely. By shifting global rainfall, the cycle executes a massive, involuntary wealth transfer, reordering commodity markets in real time. Long before the existence of modern supply chains, this phenomenon was auditing the fragility of human civilization. Archaeological records show that ancient coastal societies, like the Moche in Peru, were repeatedly decimated by catastrophic, cycle-driven floods. The physical scars of that destruction are baked into their ruined temples. In 1876, the cycle shifted the Indian monsoon, creating a brutal drought. When that climate shock collided with rigid, export-driven British colonial policies, it engineered a devastating famine that starved tens of millions of people. More recently, in 1998, a severe cycle sparked massive forest fires and economic shocks across Indonesia. The resulting inflation and resource scarcity provided the final stress test that toppled a 32-year political regime. This is a geopolitical threat multiplier. It finds the weak points in physical infrastructure and political systems, breaking ancient empires and modern governments with equal efficiency. Today, a warmer baseline climate is pumping excess heat and moisture into the atmosphere. This background warming juices the cycle, amplifying its volatility and making the resulting extreme weather far more punishing. Our primary physical defense is an international array of deep-sea buoys anchored across the Pacific. They act as a tripwire, detecting the oceanic heat cascade before it breaches the surface. But traditional forecasting has a fatal flaw, visualized in this timeline chart. Notice how predictive confidence plunges during the spring months. Physics-based models get overwhelmed by chaotic atmospheric noise, hitting a spring predictability barrier that blinds us to the coming seasons. Machine learning models are now bypassing that barrier. By training on deep paleoclimate data instead of relying solely on real-time physics, AI can filter out the seasonal noise, predicting anomalies up to 18 months in advance. We cannot stop Earth from venting its oceanic heat, but by leveraging AI to see the cascade before it happens, we can build anti-fragile food and energy systems, turning a recurring civilizational threat into a manageable anticipatory event.